Okay. Let's get started. Okay. Letting everyone else again. So today's call is going to be about um implementation of AWS IAM and VPC in Terraform. So what I would like to do is I actually wanted to make it in a way that won't be taking much of theory. We'll try to complement it with practical. And one of the best things to do is just to do like an hands-on while on the session and to see how these things work. So we are covering two things today, IAM and VPC. And in addition, we're going to use an AWS VPC and IAM through the use of Terraform. That's an infrastructure as a code. So I'll try to go through it. But if you've watched the last recording, you would observe that we were able to segment those levels into level 1 to level 5. So we'll be taking it from level 1 now. And by next week as well, we'll move to the next stage. And I hope we'll be able to just get things fast and as soon as possible. Okay, so that's the title page, and let's keep this. So, IAM is identity and access management. Just see it as a way that you be how you manage your access, your identity, something like your AD, your something like your phone book on your phone, or something like a directory. How you manage things on your assets. So the first important thing is that AWS has a root account. For example, I want to create an account now. So my email that I used is going to be the root account. That's where the billing will be charged. That's the root account. By default, the root account is the owner of the account. Is the one that has the visibility to billings and to have the right to make administrative access, like super admin on the AWS account. So the other one is IAM, that's identity and access management user. So this is what is assigned to individual in an organization on AWS accounts. For example, now I'm a developer, I'm working in a company that are using AWS. They can't just give me the root account. The root account is probably going to be the CIO account or the technology manager account or even the company account. Do you understand? So the first thing is that you don't work. That's the first principle. You don't work on your root account. You don't deploy, you don't take actions on your root account. Once you create an account with your root account, immediately you create an IAM account, IAM user account on that root account. Because if your root account is kind of attacked or somebody has the password, they can do anything. They can use your account to mine Bitcoin. They can go ahead to deploy a very expensive EC2 instance server. So you need to be able to protect your root account. It's very, very important. So the ones that you can use is IAM users. So IAM users are now partitions based on what you want to do. They call it based on what you want to do. So for example, now, if I'm in the developer group, I can have a group like developer. So anyone joining the team will just be added to the developer group. So automatically, the person is going to inherit the policy on developer group. Same thing like admin, same thing like, for example, now people that are working on data analytics team, they don't need access to your EC2 instance. They only need to read only from the database. So you can just have a group, okay, oh, these are for data analytics team. And at the end of the day, anybody joining the team, just add them directly to that group. And the last one here is a role. Role is what you give. It's a temporary access, just something that you give temporarily to a service. For example, now my EC2 instance, I want my EC2 instance to access maybe an S3 bucket, or I want it to add a CloudWatch or Lambda or a service on AWS. You know, EC2 instance is not something, it's not an entity that you can assign a user for. So for it to be able to have that privilege to access maybe S3 or Lambda or maybe Amazon or some other Amazon service. So you need to assign a role to it. So I'm going to show that as well when I log into the console. So this is the dashboard on AWS, and if you can see, these are probably what we have here. We have the user group, we have the users, and we have the role. On the user group, this is an administrator user group. So on the user group, you'll be able to see people that have access. For example, now I'm a user under their user group. So if you have AWS account, I believe most of us have an account with AWS. But if you don't have, just go to the search bar, click on IAM, and you can easily create your user. So for example, if I want to create a new user group now, I can say a new user group is let's say developer. Let's say developer. So, and what do I want the developer for? I just want them to have a power access. So that now comes to policy. Policy is the one that gives you that kind of authorization. You know, we have something we call authentication authorization. Authentication is just, okay, you want to verify yourself, who you are. Do you get who you are? So just be able to authenticate you. But authorization is, what can you access? Can you access S3 buckets? Can you access VPC only? Can you access maybe AI services on AWS? So those are the things you might need to fine tune, because you can't just give your intern an administrator access, someone that you've automatically overprivileged that person. And if anything happens at the end of the day, you as an administrator, you'll be you might need to explain yourself, or why do you give an intern an admin access, which is very important. So these are the policies here. So I can create a developer access. Maybe a developer, maybe you need a kind of a power access. Power access is an access to all AWS services except admin. So all these are AWS managed service. You can still create like a custom one just to be able to fit your own rules, but by default, the managed ones are okay if you're just getting started. Maybe you want to be able to push to your ECR, maybe you're pushing some image to your ECR, so you need all those kind of policies. So getting this policy will be able to give you this the principle of least privilege, like, okay, giving that particular user the minimum amount of access for him or her to be able to work in the environment. So it's just a matter of clicking the power user access, and at the end of the day, create a user group, and that's all. So this is the developer, and this is the permission there. Be able to see the permission. So what is inside this permission? So at the end of the day, take you through the content of the permission. So just to be able to see, okay, what's inside this guy at the end of the day. So you can see that the permission access, you have access to this analyzer, Alexa, Amplify, majorly all AWS services, except admin. And at the end of the day, I can, so for example, if a developer now joins my team, I can then create a user, just create a user here, maybe let's say Akin or Ola Dele. I don't know if anyone is bearing that. So you can create a user. So it's an IAM user I'm creating. Custom generated password. And then let me just let's use auto generated. So this option is where the user needs to change his password when he's trying to sign in. I'm very sure most of us have encountered that. Maybe they give you the default sign in to an account. So when you log in at the first time, it prompts you to change your password and all of that. So that's the feature here. You need to click here so that person will be able to change the password. So the next thing is okay, add user to a group, copy permissions, attach policy directly. So you can either do all of this, and I think the best approach is just find the group where the users is working and add user group. So I can just click on developer, And so these are the two groups. So for the one for on the developer group, and also the one for the user to be able to change his credentials when he's trying to log in the first at the first time. So I create user, and at the end of the day, I'm fine. So there's a CSV file. That's what I'm going to send through email. Okay, oh, dear Oladele, your user credentials has been provisioned. Use the step to log in. So that's just the basic setup of a user. So depends on what you want to do for the user. Maybe VPC only. Maybe the person just a pure network engineer. VPC only access, S3 bucket only access, and EC2 instance only access, database, and all of that. So that covers the IAM part of it. So this is just on a very low level discussion. I don't want to take it more very advanced because we're just getting started. But for someone that's just trying to get his hands on the IAM, I think this is suitable for him to work. So whenever the person wants to log in, he or she just go to this URL to try to log in. This guy is called an alias. It's actually your account ID, or you can actually change it to the name of your company. You can go to your security credentials here and change it. So the person can just use username, the password, and he or she will be able to log in. So I believe it's something try while on this call, or maybe through this discussion. Let's get back to the slide. So there are three ways to access AWS service. The first one is the management console. That's what I just explained now. The second one is the CLI. I think the last class, somebody asked a question about CLI. So CLI is just like PowerShell, your bash command. So something like you can just put on a terminal, you can just write a script. You want to create maybe 10 servers instead of clicking of them one by one. So you can actually just write an AWS CLI command base, push it and run it, and you're going to have it. But before you can do that, you need to install the AWS CLI configuration command. So you need to go to your terminal and install it. So I think if you go to AWS website, you'll see the instructions. It's not something, it's something very available on the internet. So AWS CLI installation, you can just see it there. Just a simple command. And at the end of the day, you have it on your terminal. So you'll be able to, for example, you want to get a list of buckets in your accounts, S3 buckets, instead of trying to log in. So you can just do AWS S3 LS and you get everything you want. So the last one is API and SDK. API is just application programming interface, so that you can reach the AWS assets. You can call them via API or software development kits. That's so we have for Python, we have for Golang. I think there's for C++. So this one is just for developers. If they want to kind of do a wrapper on their code to call AWS service or to call a particular function, maybe a lambda function that is run on AWS, and they need to get authenticated. So using the API or SDK, it really makes sense a lot. So one of the parts we're trying to use now is the API. The API works in form with the Terraform, because you're going to put your credentials and all of that, and you'll be able to call AWS service using Terraform. But we'll get to there. We'll get there shortly. So I think I've explained this. So the principle of least privilege is what I've explained, like the minimum access for someone to perform his tasks. And your IAM gives you the ability to monitor your account. You'll be able to see what is actually going, who have access to this. You can even try to do an evaluation. There are also some AWS services that works with IAM that can actually evaluate, do like a compliance check through your IAM users. For example, something like this. My IAM user, I'm not downloading this guy. So I have access analyzer. I can get I can analyze all my users. What have I been doing for the past 90 days? And things like that. So I can easily get them from the access analyzer. And as well, there's also some important factor. Let me click on my user. It's Lyman. So this is my username. So from this dashboard, you'll be able to see what I have access to. And the last time I used my access key. So for you to be able to use AWS CLI, you need to generate an access key. It's a two variable value. You have the access key and you have the secret access key. You have the access key and you have the secret access key. So you can easily get them. Yeah, it is. So this is it. So your access key is for you to be able to, they call it STS, security token service, just like a token, so that you'll be able to authenticate through the CLI or the API part of it. So and it shows that I used it 12 hours ago, and all of that. So another thing is MFA, multi-factor authentication. Instead of, aside from using username and password, just like another layer of security. So we have a lot of MFA. I know most of us use them. We have Google Authenticator, we have Microsoft, we have FortiGate for Authenticator. So it's something you can download on your app, then integrate it directly to your account. Just click on Assign MFA, and if you let me, let me just assign MFA just to show through. So assign MFA, put the device name, maybe 100, 111, just any name you want. So Authenticator app. So if you go to Play Store, you'll be able to see a lot of Authenticator. But I personally use Google Authenticator for that. So at the end of the day, once you go to your Authenticator, you can just scan this barcode. Once you scan it, it gives you two values, like a 6-digit number. Just put the bit number consecutive here, and you add MFA. So that would be like additional layer of security if you want to enter your account. So for example, if somebody have access to your account, your password, they can't have access to your MFA because it's personal to use your mobile, or else the person also have access to your phone as well at that same time and get the MFA code. So the MFA code is generally like a 6-digit number. Put it here. The first one, second one, just follow instructions and you add it. Because I've added mine earlier the last time, so that's why I don't need to add it again. But maybe I have another account I want to add. I can just add it and I'll be fine. So the last date I added it was December 14, 2024. So let's go back to our slide. Now let's go back. Let's come to the real work of the day. Because the reason why I explained the first part is that you need your IAM visa. This is not how you can work without your IAM visa. So this is the project we are trying to work on today. So let's just give like an a dummy variable, like a dummy company. Let's say Solis application. So they want to implement their infrastructure on AWS cloud. So as a cloud network engineer, you are meant to set up the infrastructure for them. So the VPC, the subnet planning, and all of that. And I've explained that last. One of the first things you're going to do is you need to plan the subnet. So this is the user story, what you need to do. So this is what you've been assigned to do. So you need to plan the subnet, data compliance. They said the region must be in USA. So, and the third one is that you need to create 3 VPC. And another point here is that you need to implement an highly available system. So can someone try to give me an idea what an highly available system means? Anyone there?
Hi everyone, good morning. My name is Prince Will.
Okay.
A highly available system is a system that has replication across availability zones, maybe regions, so that if eventually there is an issue with any of the data centers, you will not lose all your resources.
Okay, yeah, thank you very much. So that's exactly what highly available system is. So it means that based on what is it promise? Sorry, I didn't get the name.
Prince Will.
Okay, Prince Will. So thank you very much for that response. So exactly based on what he said. So just something highly available in case once is one easy is bad. We explained easy last week that it's just something to have an highly available system, your network, so that maybe if an easy is down, you can go to the second easy. And by implementation, architecture design, you go through is 2 easy minimum. The design should have minimum of 2 easy. That's design. And the last task, the user stories that was assigned to you, maybe on your Jira board or on your Scrum, or your Kanban board or something, was you need to implement it as an infrastructure as a code. So all of this task is being assigned to you. So how do you start it? What's going to be your plan? Being the cloud network engineer. So the first thing is that you need to plan the subnet. So that goes to the question: what is a CIDR block? A CIDR block is a classless interdomain routing. I won't go deep inside networking because it's more of a networking concept. But what I actually want to use there is that the CIDR range is what that determines the number of IP in your VPC. So one of the things you need to plan is that you need to plan for scalability, for future scope. You can't just put a very low CIDR range, CIDR block to your VPC, because at the end of the day, it might get exhausted. So there is an advanced way of attaching a secondary CIDR range, but don't let me take it to that level now. But basically, by default, the design is that if you are starting, you plan very well for the scope, for the future. So you use something like /16, /20, /20. Some people even use /10. But based on this design we are doing, I'll be using /16. And what does /16 means? You can read up the RFC. This is the request for comments about CIDR routing. So I don't want us to deep dive to that for now. But so there's a URL, CIDR.xyz, that will shows you the number of subnets. Now the number of IP address you can see for each CIDR block. For example, this is a subnet now, 10.88.135.144/28. It means that the total number of IPs that I can use in this subnet is 16. So automatically, I can't use this kind of CIDR block in my account. What I'll be trying to do is something like /16 /20. I get my point. So if you use this kind of thing, AWS cannot even permit it for a VPC. I think the minimum you can do for a VPC is /20, is 24, 25. Yeah. So you can just go to this. There are a lot of tools outside there, but I think this one makes it more easier. So let me just go to CIDR.xyz. Let me just put /16 here. With /16 means that the first, this in networking, because something first, second, and third and fourth octets. This box here is the first octet, second octet, third octet, and fourth octet. So the third and the fourth must be free, must be 0. That's what they call /16. Each octet is 8. So this one is 8, this one is 8, this one is 8, this one is 8. So 8 plus 8, that's 16. So it shows that if they say something is /16, it means that the first 2 octets has been occupied. That one is not changing. So automatically, it's the last 2 that will be changing. If they call something /24, it shows that the first 3 octets is constant, is not changing. But the last octet, which is the fourth one, will be the one that will be changing. If they call something is /8, automatically, they call something is /8. Let's put it like this. Let's say /8. You can see that about 16 million count. So it means that this guy will be constant, the first block will be constant, but the consecutive ones will be changing. So in our scope, we are using /16. So that shows us that we have about 65,000 IP if we are using the /16 subnet, which means that these two blocks, this one, the third one, and the fourth one will be changing. So in this CIDR block, so once we've been able to design our CIDR block, this is what we want. So we can now break them down. So inside this /16, we can now take the subnet based from this /16. So we can now take /24, /25, because the maximum number of IP you can have here is 65,000. So we need to start breaking them from these old CIDR blocks. So let's say 124. So let's say I'm using this for my public subnet. So it means that my public subnet, I can have an IP of 256. And the bigger picture is 65,000. So we're just trying to break it down. Just okay, well, the VPC CIDR block is /16. Okay, the subnet, let's give them /24. So irrespective, at the end of the day, in my subnets, I can allocate 256. But in this 256, you can't use 2. Remember the last week I explained that there are some IP you can't use in your subnets. They are like 5. They are like 5. So if you start if AWS want to use give you at the end of the day, AWS is going to take the first 4, 0, 1, 2, 3. AWS is going to take that, so can use others. So you need to plan all these things ahead. So at the end of the day, you won't be like, okay, the IP has exhausted, especially when you are planning Kubernetes networking. If you are not using a CNI, you want to be using the VPC, you need to plan it very well, because ports, services, they use a lot of IP. Now, at the end of the day, you might be stuck that you don't have any IP address to use for your Kubernetes. So don't let me go there now, but I'm just trying to emphasize the planning of subnets. And you have a lot of tools you can use. This is one. We have IP subnet calculator, and we have some other things that we can use as well. So I think am I a bit fast? Any reactions? Are we following? Are we good?
Okay, I'm trying to wrap my head around this subnetting.
Okay.
So I understand that when you have /24, it means the third octet, whatever number you have there, will remain constant. Why?
Yes.
On the octet, okay. And in each octet, we have about 256 spaces.
Yes.
Okay, so if we change this slash to 25, what will now happen?
So if you change to 25, we're going to have 120. It's binaries. So I explained that each of these guys are 8 bits. They are an octet. So you have 8 bits in each of those blocks. So if you use a binary, binary 0 to 1. So if you convert binary to base 10, so this first guy, the first value here is 128. The second one is 64. Is this 64? I can just remember. Yeah, 64, 32, 16. Exactly. So at the end of the day, those values will now accumulate the number of IP address you can have. So if you have 25, automatically means that this first block is out of it. You can't use it again. So you need to start counting from 64 downward. So if you sum 64, 32, 16, 8, 4, 2, 1, it's going to give you 128. Do you get my point? So if I use 26 now, 26, it has already taken the first and the second byte. So 128 bytes is removed, 64 bytes is removed. So what we start counting is we start counting from 32, 16, exactly. So if you add all of them together, it's going to be 64. So that just so it's more or less like binary, exactly. So what we'll be planning now, this is very important because this planning subnet is even the fundamental. So once you be able to get it, you can easily plan your infrastructure very, very well. So let's get started. Let's go back to our slide. I think this is clear, right? Any other question again?
No, thank you very much for the explanation. It's clear.
You're welcome. You're welcome. So for the VC planning, so I think don't let me skip those questions. So I think we've planned this subnet. So now let's plan the subnet now. So planning the subnet, we now said, okay, let's give them /16, each of the VPC. This is our web application. And that's the one, our web server, where our web server is going to be. Web server is typically that the servers that people will be able to reach from internet that was going to expose our application. So the database is going to be on our data tier. Maybe that's where we have our database, our MongoDB, MySQL, and all of that. The backend, that's where we have our code. So we want to try to split them. We are using a kind of an MVC, model view control design, a three-tier architecture whereby the front end, we have the logic tier in between, which is the backend, and we have the database, which is third. So the front end, which is the web app, is going to be at the first one. That's what people is going to reach. The front end will call the back end. The web app is going to call the front end, maybe through API or through any connection. And the back end is going to call the database. So that's how a MVC, a model view controller design. They also call it three-tier architecture or some of that. So basically, so what we're trying to do now is that our web app VPC, we give it 10.200/16. Database VPC, we give it this subnet, and this guy as well, give it this subnet. So for compliance, they said the compliance is that all of us must be in US. So you need to check AWS region. You need to check AWS region, and let's check. So these are the regions we have. So which one is in US? Out of them, we have North Virginia, Ohio, California, Oregon. So we can either choose any of these regions. Since the compliance said that we need to be in US, assuming we need to be within Europe, we need to use EU Central, EU West, and all of that. For example, if it's Canada or something, they have their own region. If it is Asia Pacific, they have their region. So this is also important because of our risk assessment and this GDPR, this data privacy stuff. So that's that. Let's continue with the slide. So another thing, to create an highly available system, so we have to create minimum of 2 subnets in VPC. So for example, we have private subnets, we have private subnets, or we have public subnets. So we can create 2 private subnets and 2 public subnets. Are you following me? So, and another design there is that for private subnet, the third octet must be even. Should be even numbers, starting from 2, 4, 6. While the public subnet should be odd. So at the end of the day, for example, let's say web app VPC. What we need to do is just to come here. So 10, 1 means that that's a public subnet /24. So it means that for our public subnet A, we'll be having 256 IP. If it's the private subnet 2, so it depends. It actually depends on our design. So, but generally, this is just to get to an overview to give us how design is being achieved for implementing infrastructure on AWS. So we can use one, let's say one, so that anybody that is coming to your network, we have this kind of a template to be able to use, and things won't just get I call it disarranged. So this is web app VPC. So all VPC are located in US 1, 2 subnets for each VPC. Private subnets should be even, private subnet should be odd. So that's what we're going to do today. But I'm going to do so a little part of it. You guys are the one that will do the most part of it. I'm going to create web app VPC for you. I will show you the Terraform file and all other things, and I'll create some subnets using Terraform as well. But at the end of the day, you will now be the one to create the 3 VPC at the end of the day. So that's going to be like an assignment or something, or a practice so that you can do it and you document it. So I think I said it in the last class, documentation is part of your growth. You must be able to have a good documentation. You can just have like maybe a markdown or something on Medium or something like you can use it to document and it's public. So people will see what you've been able to achieve, what you've done. So you can have like a markdown or a Dev2 account or a Medium account or any of them so that you'll be able to put and document what you've been doing. So I'm going to do this alone. So you guys might need to do this. So after you do it, you can now send me your Terraform file, something so that we can just check against the next class where we'll be moving on to another level, another service. I hope everyone is following. I hope we are still good. It's not, are we still together? Okay, I can see Yang. I think it's only Yang that responds. That gives a reaction. All of what about the others? Are we good, or is it okay? I think I'm seeing some reactions as well. All right, as I can see from Prince Will, from Mundubusi, Obitade, yeah, I'm seeing some response. So I think somebody has a question. Can you proceed with your question? Somebody raised his hand. Maybe it was a mistake. Okay, so now let's go. Infrastructure as a code. So I want us to just get started as soon as possible. I don't want us to take time. That's why I'm taking, I would have said I should just split manual and manual VPC and all of this separately. But let's just get started. Let's try doing things. So Terraform, you've been hearing Terraform. It's not something that, it's just like a statement file. You just write an instruction. If you are a developer before, you write a code for something and it does it. I want 20 VPC. You tell him I want 20 VPC and it's going to create it for you. That's all. So it's not something hard or something complex. It's just a matter of grabbing the fundamentals very well. So infrastructure, Terraform is an infrastructure as a code. Your own infrastructure can sit on a Terraform file. And at the end of the day, it creates what you want. It creates it for you. And at the end of the day, that's all. You are good. You create it. And at the end of the day, when you guys use it for a development account, maybe you are using it for POC or anything, you can just have the state file, you keep it. You can even migrate it to another place with your state file. So Terraform is a very important skill to have and a very good knowledge. And it's not a matter of being able to be an expert, but you need to just get started. You need to start doing it by yourself so that if you encounter an error, you'll be able to troubleshoot. And before you get it, you're already an expert there. So that's the configuration file, and the extension is .tf. For example, if you have a Python file, call it .py. So this one is .tf, and it uses is there no, there is no exercise that we're giving last week. So we're just giving an exercise this week. So so it is an HashiCorp configuration language. Okay, I'm coming, man, and let me just try to go through Terraform so that I'll be able to take a question. So the Terraform is using HashiCorp. That's owner. That's the owner of the Terraform guy. Terraform is written in Go at the back end, but it's TF file, and also it works with different provider, AWS, Azure, GCP, VMware, name it. Even with Cisco devices, I've implemented configurations on Cisco firewalls, Cisco ACI using Terraform before. So it's an interesting tool for you to have. So it's going to be like a Swiss knife, army knife that you can use it for anything. So that's Terraform. Once you know it, you can use it for anything. It's just like Ansible. Once you know Ansible, be it network, servers, anything, you're on the go. So that's the provider. The states, I've explained it, that's where your configuration file is going to be, and at the end of the day, you will be able to monitor your state. The state is all your infrastructure, how it is being deployed, what did you deploy, and all of that. That's going to be on your state file. And there are also some advanced implementation they do for state file. They either lock it, they put it in S3 bucket, or they either lock it on one of these guys, an AWS service that you can use it to lock your state file. So and the last one is plan and apply. That's why I said Terraform is simple. Once you have your configuration file, you just put the first thing to do is Terraform init. You initialize Terraform init, INIT, Terraform init. The next thing is Terraform plan. And the last thing to do is Terraform apply, run, and you're done. So just cross your leg, be taking your tea, and everything is being deployed. So no stress. I think Enyade, can you ask a question? I think
Thank you. Good evening, everyone. Or good morning, sorry.
okay.
I just wanted to confirm the subnet planning, which was in the other slide.
Okay.
The subnet planning, where you highlighted the public IP, the third octets must be an even number. So my question would be that, is it a guide? Is it like a guide from AWS or how?
No. It's not AWS guide. Yeah,
Okay.
it's not AWS guide. It's just something that can make our design to be easier for us.
Okay.
So that you'll be able to segment it that, okay, the third octets are for public subnet, the third octet are for private subnet. So in your network, maybe you do a trace or you see an entity that's that IP, you know that automatically this IP is coming from a public subnet. Do you get my question? Do you get my response?
Okay.
That's cool. Something like it. Yeah. So so this is if you want to install Terraform, this is a link. You can install Terraform. It's easy. Just some basic command and you're done. So the GitHub, so at the end of the day, I'm going to put all these guys, all my Terraform files on the GitHub repo. So you can actually pull it and clone it and you see it. But before I clone it, I want you to do your own first. I don't know how we're going to do that one, Sha. But there is nothing in this repo for now. So if you can't see anything for it now, but I actually want to see your own before I'm going to push my own. But either ways, I'm still going to push it there. But I just want you to follow the class and see through what is being done. I think John has his hand. You can ask your question.
Okay. Yeah. Good morning, everyone. Good morning, Sulaiman. So, the subnet planning, right?
Okay.
Yeah. I also want to ask if you are segmenting the web app from the DB from the backend, you know. So, is it also possible to use one subnet for the entire of the whole infrastructure? I mean, just the web app,
yes,
and backend.
Yes. If you are very good with subnetting, you can do like a VLSM. So all of them, maybe you want all of them to be on 10.200.10.00/8.
Yeah.
So maybe this guy will be on 10.00/20 or something like that. If you want all of them to be on the same subnet, maybe like 10.100. Let me come here. Let's say this is 10.0.0.0. So maybe you want all of them to be on this 10.0.0/8. So you can just do a VLSM.
Yeah.
You have about 16 million plus IP to use. So you can just do a VLSM that, okay, web app VPC should be 2, should be 10, should be 10, maybe 10, 20. The other one should be 10, 20, 20. The other one should be 10.
I mean,
so it's still going to be within. This is going to be within that mean 10 subnets. Do you get my point?
Yeah, I got it. I got that. So this is what I'm saying. For instance, now this 10.30.0.0/ let's say /24 now. That's a single network, right? So is it possible to? I mean, can we also do the web app, the DB? I know it's not. I mean, by standard, it's not really advisable, right? Can we put all our web backend database in just a single subnet without breaking this CIDR?
No. You need to break the CIDR because they are VPC. They are isolated environments.
Okay, got
Each of
it.
them has all of them are isolated environments. So it's not like it's connected by default. So they are like isolated. So each VPC is isolated. This guy cannot talk to this guy until we did some extra configuration. This guy is on different gateway. They are in different tenants.
Yeah, I got that. Thanks.
All right. You're welcome. So I think we are done with the slide. So let's go to the real deal. No. Can you see my Terraform something? Can you see my VS Code?
No.
No.
You can't see my VS Code.
No.
You can't see.
Okay. Let me stop sharing. And
Can you share the slide with us, please?
yes, I'll share the slide. Don't worry, I'll share the slide, but I won't share the GitHub link now. So, can everyone see my screen?
How about we don't.
Yes.
Yeah, we can.
Okay. So so I said let's get started with Terraform. So basically, Terraform has the basic structure is your provider. You know, I mentioned provider. So it's a required module. Let me put it that way. It's a required module. So provider, the first line, provider AWS. So this line is a required module. You cannot change it. It's a constant K. I get my point. I don't know if you are getting my point. So this this is the provider. So it shows that okay, Terraform, which provider are you using? I'm using AWS. If you want to use Azure, provider is going to be Azure. If you want to use Google, the provider is going to be GCP. So the provider matters. That's the first thing. Okay. You have a question?
Yes. Is it possible you increase the font a bit?
Oh, okay. The view, right?
Yeah.
Okay. Is it better now?
Oh no.
I'm coming. Can just 1 minute.
Maybe a bit more.
Let me just
It's getting smaller.
Can you see my screen? Is it better now?
No, it's very tight.
No, it became smaller.
Yeah.
Okay, so this is what is
Okay,
happening. You need to change your view on Zoom so that you have full screen, so that you can have the screen.
It's actually full. It's actually full.
No.
Is it better now?
Not you, Sulaiman.
Can you see?
That participant.
Okay.
But
Is
then
it
you
better
can.
now?
But this
Are you
is
seeing
tiny
it?
actually.
No, I can't see, but let me try what is suggested.
Can you see it now? Is it better now?
Exactly.
Yes.
This is
it's
okay.
better now,
This
right?
is
Okay, yes.
Yes.
Yes, this is better.
Yes, this is better. Yeah.
Okay. So this is the main tier. So we've all agreed that we are using AWS as our provider. So the next guy here is resource. So the resource is what you want to create. I want to create VPC. I want to create EC2 instance. So this guy is a required constant K. It must be in that way. That's the structure. Just like the way you program in Python, you need to, if you want to declare a class, the class is the default way. That's the normal standard. So this main is a custom value. You can put anything you want, but you must make sure that when you are referencing it, you reference it with what you use. So all these things, all these guys are like ID. You need to be able to reference it at the back or at the end of the day. So basically, people use main. Okay, this is your VPC. So this is just your resource module. And inside this your resource, we can see that the opening and the close tag. Just follow the opening and the close tag. These are the opening and the curly brackets. You can see. Just follow it the way it's. That's why I like VS Code. to using it to work, but it's going to make sure you have a very good view of your of your configuration file. So the CIDR block, you can see var.vpc underscore CIDR. That one looks strange, right? Don't worry, we'll get there. Enable DNS host name, true. Those are properties. So if you go to the website of HashiCorp for Terraform, all these ones are default values, something you will see if you are creating a VPC. So that's what you're going to see. And the tags, I'm coming, John. I'm gonna take the question. Tags is like the name, what you want the name to be. Environment, you can see var dot environment. And another thing here, you can see this dollar sign. Dollar signs means like a variable, right? Anyone that is used to Python will know that dollar sign is a variable. So we're actually referencing a variable here. So now that takes us to what we call variable file. This is what we call a variable file. So this variable file in AWS. So you just like a variable block, the name of your variable, and the type. Is it a string? Is it a string? Is it a boolean, or is it an integer, or is it a list? That's why if you write code very well, Terraform is still bit, so you're going to be like on an easier side. So you need to put the type. Is it string? Strings are like my name, your name, something like that. So integer is like numbers, something like that. And but majorly we use string most of the time. We use string. And if you want to use a string, you need to quote it with double quotes at the back of. So that's why. So anywhere you see AWS region in your code, the value that is there is US East 1. Are you getting me? Anywhere you see VPC CIDR, the value that is mapped to it automatically is 10.200.0.0/16. So instead of variables is just to be able to have a kind of reference. Instead of me putting 10.200 everywhere across my code, I can just reference this variable. I just use var dot VPC underscore CIDR, and I'll be fine. So same thing as this guy, same thing as all these guys. I think I've initialized as a variable and I put the default value there. The instance type as well, my key name, because I'm going to create a server. The environment, the name of the environment is web application. I put the environment name as well. So these are the variables I have. So I can easily reference my variable in my main.tf file. The main.tf file, you just put it as main. You can use any name. But when we start, we are going to move further to modules in Terraform. So when we go to modules, it's kind of an advanced level Terraform code. So modules is now a way by we can now start calling modules from where they are to our main.tf. But for now, let's just stop with this. So this main.tf is just a name, the name of this file. You can call it vpc.tf, you can call it sulaiman.tf, you can call it any name. Doesn't mean. So I think we all understand where this var.vpc CIDR, what it means, right?
Yeah.
Okay. All right. You have a question.
Okay.
Wow.
Yeah. Thank you so much for the explanation. So this Terraform code, right? So how do we get the templates? Because of to be honest, most of us we are not familiar with these templates. So how do we get the templates? Is this something we can get from Azure, edit, then fine tune to our own taste or something like it? Where can we get the code, or do we need to? I mean, how do we just generate the code for?
Okay. The code is actually on Terraform. If you go to Terraform, AWS Terraform, there are some examples of something like this there. There are examples of something like this there on AWS. Just type AWS Terraform. It's going to take you to the AWS Terraform code structure. But I'm still going to share this Terraform file to all of us. I'm still going to share it.
All right. Thanks.
But it's just something you can easily find available. You can see it anywhere. You can even ask ChatGPT itself. But I think the main important thing is to understand what you ask.
All right. So another thing is, sure, I got that. Thanks. So another thing is, we're trying to deploy some instances in. I will reference Azure, right? So there is a part there where you can see the templates, for deployments in case you want to automate things, So is it something? Is it relating to this code?
Okay. Azure use Azure Resource ARM. That's what
Yeah,
Azure
yeah.
use. All those services, they also have their internal infrastructure as a code. For example, AWS has CloudFormation. It's just like
Yeah.
Terraform, but it's internal to AWS. Azure have Azure ARM templates.
ARM, yeah.
Google Cloud also have their own. So those are like internal to those vendors. But this guy is Terraform is like an open source. It covers all of them together.
Okay. I got that. Thanks.
You're welcome. So, because of time, so let us try to speed things up. So, I think last week I explained AWS Internet Gateway. Like that's the guy that would, if you are going out, that guy must be attached to your VPC. It's just like your telephone line. You don't want to call anybody outside your house. You should be able to call that person through your telephone line. So to be able to call anybody from outside and from anybody from outside to call you, I get it. It's your VPC must have an internet gateway, just like public IP attaching it to your house, to your VPC. That house explanation. I think I'm very used to it a lot. So you call it, this mail is still there, but this guy is constant. This resource, you can see all of them are resource. This main is like a custom custom value. You can put anything there, but make sure you reference it directly. So these are just ID. These are ID, not name. These are just ID because they are called resource ID. And what is being you can see that it reference the ID of VPC. You can see that VPC ID equals AWS underscore VPC underscore main underscore ID. Where is this guy? This guy is up here. I get to my explanation.
Yeah.
Okay, if you don't understand, please call me back. I will be glad to explain further. So this guy, because this guy needs to be attached to a VPC, that's why you need to reference your VPC ID. If you understand this ID of a thing, you'll be able to you'll be able to troubleshoot any Terraform error because you know which one is not working, which one is working. So it references all these ones are tags, the name, the environment. These ones are just tagged. The subnet as well to create a subnet. It is, a subnet, you need to reference your VPC as well. So that's why the VPC ID is there. That's why your subnet, you can see your subnet CIDR block. You can see the public subnet variable. And you can also see the region, US East 1A. We have regions and they are A, B, C, D. So we are putting this public subnet in US East 1A. And this is the name and all. Private subnet, we are putting it US East 1B. You can see that we are referencing a particular variable here. So you can see this $sign. And as well, route table. I explained last week that route table is where you have your routes for people going outside or people going inside, like where you will need to redirect, okay, like a pathway. Okay, any traffic going to internet or pass through the internet gateway to go to internet. Any traffic going to maybe another VPC, take the route. Any traffic going to your VPN connection, take this route. So that's what route table is. So route table shows you the paths. Okay, maybe you're at a junction, like a map. Okay, my traffic, I'm going to the internet. Who should I use to go to the internet? Okay, use internet gateway. That's why you can see that 000 is a default route. That means anything. And your gateway, what am I going to use to reach to the internet? I'm going to use internet gateway. You can see that we reference internet gateway ID as well. Internet gateway is up here. It's something, you can see that this is it guy here. So just the first guy dot the main dot I. That's how the reference is being done. This is the route, and it's been tagged public route table. So all these ones are just tagged. Same thing, your private route table. We don't have any route there yet because private route table. We don't want it to go to internet, so we just leave it like that. Route table association, we need to associate our route table to the public, to the subnet we are using. So public route table is associated to public subnet. Private route table is associated to private subnet. So it needs to be done because that's going to give each subnet, okay, I'm in the private subnet, so let me check my route table. What is on my route table for me to go anywhere? I'm on the private subnet. What's on my route table to go to anywhere? So that will give me like a directory, okay? You pass this way or you pass this way. And security group, I explained security group last week. I don't want to keep repeating myself, but security group is just like an instance level, like the security that is done on the server itself. And I explained that it's stateful. It's stateful. It's stateful means that you can only allow inbound calls. Outgoing calls is default. Outgoing calls is permitted by default for going outside. But for coming inside, maybe you want to reach your application on port 8080. So you must create a security group and inbound to allow connections from internet on that port. That's how security group works. And there is no deny, it's only allow. It's only allow, and it's stateless. And it's just like somebody that wants to enter your house now. You give that person an invite, okay, come to my house. So once they come to your house, once they open your door, maybe they need to put a pin to just come inside your house. So once they come inside your house, if they are going out, you don't need to enter that pin again. That's how security group works. So once you're able to come inside, for you going out is default. But the other one, which is network access control list, that one is just like your office card. If you are going in the morning, you tag. If you are going out, you tag. So that one is stateless. But this security group, as far as you are coming in and you are allowed, you're going out is sure banker. So sorry for using sure banker. So this guy this is how the structure is. Wants to allow for 22 because it's a jump server. This is just like a test. Okay. Like want to allow 22. So anybody on the internet should be able to tell SSH to this server. So that's what you want to bring about at this point. Hello.
Hello, Suleiman.
Yeah.
Okay, thanks for your lesson so far. I don't know. The presentation is not moving. I don't know if it's with me alone.
Yeah, I'm not moving.
I'm
still explaining.
Okay.
Yeah, I'm just explaining. But I'm moving now. I think I'm moving it now. Maybe it's the network. Is anybody experiencing that as well?
Nope, everything is fine here. But we can see your cursor showing that it's moving.
Okay, yeah. At a point, I was not moving at all, but I think I'm moving now. So this part, this security group, is just what I've just explained now, and that's how it works. So the ingress, you can see that the ingress is the one coming in. The egress is the one going out. You can see the egress going out is 00. That one is by default allow anybody to go out. But for the incoming, you only allow port 22. Anybody coming from outside that wants to reach this server on port 22 should be allowed. And please note it, there is no deny. This kind of question, they really ask it a lot. Difference between security group and network access control lists. And you need to explain. So it's not something you need to cram, just simple explanation and you are good. So this is the ingress and the egress, this is the tag. So this is EC2 instance. I think admins have a question.
Okay, can I go ahead?
You can answer a question. Yes, please, can go ahead.
Okay. Yes. All right, so I was just going to ask, for the ingress, where you have, if you have multiple ports that you need to state, how do you state them? What is the, how do you differentiate one port to the other? Okay, so let's say, for example, you have port 22. Let's say I have port 23. I also want to add. I have port 42 or 41. I also want to add. So how do I input them? Is there something I need to? Is there a command I need to add to make it stateful?
Yeah.
Be stateless?
So what you're going to do is that, yeah, thanks for that question. So what you need to do is just like creating another group here, just something like this again. I get it. So just something like this again that is going to encompass so you just have to so you put from port 23 to port 23 TCP, and you put the CIDR block that you want as your source here as well. Do you get the response?
Yes, I think I get that now. So I will repeat it, then change the port number.
Yes, yes. So there's also a way to write some kind of Python listing. So that Python list can embed the port you want to expose and add it together and put all of them in one security group. But I believe we're going to get there in the next class. But basically, let's just start with this for now.
Thank you very much. Once again, I'd like you to also still mention when you were saying something about the security group and the you mentioned that again. I think security group and the
Network access
Oh.
list.
network access list. Yes. All right. So you said a difference. So I think that thing in exams, I think it often comes out. I want you to just maybe point at it again. Thank you.
All right, you're welcome. Welcome. So security group and network access list, both of them are security features, but one happens on the instance level, the other happens on the subnet level. I get me. So you only attach a security group to your instance, maybe your EC2 instance, your Lambda, or any of your service, basically EC2 instance. But network access control is you attach it to your subnet, and it's stateless. If you come in, for example, if you come in, if you use your card to tap into your office, if you are going out, you tap out again, it doesn't know that you've come in before. So that's how the network access control list works. So for you coming in, you need to be explicitly allowed. You need to be whitelisted. For you going out, you need to be whitelisted, and you can allow and deny on access control list. There's option to allow. There's option to deny, because it is attached to a subnet. But your security group it is stateful, and you can only allow, you can't deny. So once it's just for server for reachability to your EC2 instance. So once they're able to reach your instance, automatically they will be able to go out. So that's the stateful and the stateless difference. Do you understand that?
Perfectly. Thank you so much.
You're welcome. You're welcome. So these are security groups. So at the end of the day, let's create a server and EC2 instance just to see what we've done. Like maybe is it in the private subnet, the public subnet, or something. So that's why this guy is there. So I told you that this resource is the format is like how do I call it? Like a required command. So because you are calling the resource for AWS EC2 instance, that's what you are doing. So this web server, you can call it jump server, can call it anything. It depends on me. This one can be your own, it's customized. But this guy is constant. Please don't let us forget that. For AMI, you can easily get AMI from AWS. Let me show you how to get AMI. What screen are you seeing now? What screen are you seeing now? Can you see my AWS account?
Yeah. Yes.
Okay,
Yes,
so okay, so AMI, this is instance. So you can get it on two ways. AMI catalog, you can easily get it from there. AMI catalog, you just click on, let's say all Linux. Maybe you want to stay, maybe Ubuntu or anything. So this is what they call AMI. We have 64-bit architecture, we have 64-bit ARM, and we all know the difference. So this is the AMI ID. AMI is specific to region. You can see that in US is one region. So if I go to maybe Mumbai or Sydney, the AMI region for this particular server will be different. Hello, can you hear me?
Yeah, we can hear you now.
I think I don't know. I lost my
Yes.
internet. Both my my internet went off. I don't know, Sha. Actually, don't know why, but it's fine. So are we all back? So then let me just I think
Yeah.
we're all back, right? So let's continue. Okay. Mhm. I think what I'm explaining AMI last time. I think it's slow a bit, right? It's slow.
Well, not really, we can hear you.
Okay. So I'm explaining AMI. So AMI is different based on region, and it's different based on region, and you need to be able to copy the AMI to be able to do your stuff, what you want to do. So you need to be able to copy it. It's per region. It's 64-bit architecture, and you use it. So AMI is based on region. Please note it very well. So for
First,
example,
Sulaiman, could you use your Windows font?
I should
I
increase
mean,
it or reduce it.
yeah, zoom.
Okay. Is it better now?
Yeah, I think it's okay now.
Okay. So you can see that the AMI, these are the AMI. So you need to reference it in your Terraform file. That's the static way. The dynamic way is to call data source. There's a way you can call data source. You can call all these AMI data source from Terraform and then filter with the name. So I can easily filter with maybe Ubuntu 2020 LTS. So it's going to filter with the name and get me the AMI that I needed. It's possible as well, but let's take it step by step. And let's put it statically for now, and we are good. So this is what I want to bring down, like the AMI part of the thing. So can you see my Terraform file now? What are you saying now?
Yeah, we can see the Terraform now.
So that's where I copy this guy. This is where I copy the AMI. If you check, the AMI is going to be the same for US61. For Ubuntu 22, I use Ubuntu 22 LTS. So my instance type, if you can remember, I reference it as my variable here. I've created a PEM file already. So this is my PEM file, like SSH key file. So I've referenced it already. So it's going to pick that up. And as well, I hope I've not edited anything. No. So and as well, reference the subnets. So you need to reference the subnet, you reference the key name, and put the tags there. And I think basically this is what you will do. You will do if you want to create a server on AWS. You need the AMI, the instance type, the subnet, and the security group. So the instance type, we have a lot of instance type, but I think I use T2 micro. So the default is there. So just preference it there. And we are all good. So this is just a basic highlight of how to create a VPC, a subnet, route table, and also attach that that instance to a subnet. Do your internet gateway and all of that. This is just like a rundown assessment. So now let's try it out. So you must be, another thing I need to specify is that you must be located at the folder where your Terraform file is. So if I do ls here, ls, you can see ls is showing that my folders are in this directory. So my folders are in this directory. So that's what I want to do. So the first thing we need to do is Terraform init. I think I've done that before. Terraform init is to initialize, to be able to call all the resources you've called before. So you're able to call all those resources, all those modules is going to be going like the ability for that guy to go to AWS. So this Terraform init is just like you are calling all those modules, all those AWS, all this guy, all these resource, security group, route table. You are calling those resources. Okay, all these guys will come to my server now, and I access you. So the next thing now is Terraform plan. Terraform plan is that you want to see what you've done. So Terraform plan is going to give you an highlight of all your resource you've done, just like an overview of what you've done since and what is going to be created at the end of the day. So 10 to add. You are creating 10 resources. And if you check it very well, it's going to be 10. Now let's start going. So each resource is this plus. Just use this outer resource to tag each of them. So if you go through them, so this is what is going to create for you at the end of the day. You can see in the VPC option, this is an EC2 instance option. There is a lot of variable you can add. But basically what we need there is what we just added. So this is what is going to create for us at the end of the day, VPC and all of that. So now let's the next thing, since you've planned, so this plan shows you that your Terraform is fine. If you plan and you are having error, you need to check again. Right, what is happening? But if you plan and you see you see the number of things to add, 0 to change, 0 to destroy, you know that we are fine. So the next thing to do is, I think they even said it here, is Terraform apply. So you now do Terraform apply. Terraform apply is that you want to apply all your configuration file to your AWS. So Terraform apply is in two ways. I can do Terraform apply. It's now going to, this guy will ask me that, okay, do I want to approve? I will say yes. Or I can do Terraform apply -- auto approve. Doesn't need to give me that prompt again. But for the sake of learning, let's do Terraform apply. So it's going to go through the plan again. It's going to go through the plan again. And can you see the prompt? It gives me a prompt. Okay, put yes. If I put no, nothing will be done. But if I put yes, it start creating it. So let's go. So I put yes, so it's creating the VPC. You see creating. At the end of the day, it's going to be said done. Once it's done, go to your AWS account and you check what has been done. And we are fine. Are we together? Is it clear?
I have a question.
Yeah, it's
Yeah, I'm okay.
Okay, so I just want to get clarity on the Terraform file you created for EC2 instance, because I realized that, okay, for security group you created it separately, then the EC2 instance. So is there a way we connect the EC2 instance to the security group that we created?
Yes, we're able to reference. Let me come here. We're able to reference the security group. So we now reference it under this guy. Not this guy. We reference it. So this guy is saying that
that's the name.
My pen file. Yeah, that's the name. So this guy is saying that my pen file did not edit. So let me go and check my pen file.
Okay. So sorry, Slama. Before you proceed. So now I have two questions, right? The very first one is, from the beginning of the Terraform, I couldn't see where you link the Terraform service to your EC2 instance, right? I mean, the connection between the Terraform. Identifying that this is the tenant I'm speaking to, right? That is one. Two, the variables. Can you go back to the Terraform?
Okay. I'm coming. 1 minute.
That's right.
Okay. All
right, so let's scroll up on the Terraform script. Scroll up a bit. So there's this portion where we have list of other variables that we can use in Terraform also. I mean, can you scroll up to that part?
Well, I didn't get that. Where's
the code? I'm sorry, it is the during the runtime, the other console, the main console. Yeah, scroll up on the main console.
Okay.
Yeah, scroll up.
Okay.
Yeah, keep scrolling. There's this part that shows other variable that we can also use. Hey, I think this is it. Yeah.
Yes, other variables like we can also
that we can also use, right? So
like other variables, if you are creating an EC2 instance, you can also use some other variables attached to it. But we typically use what we want.
Need.
what we need exactly. So
Okay.
that's
Okay. Okay, that resolves it. Thanks. Thanks. So how about the
sorry.
connection to your tenant?
Yeah, exactly. So the connection to the tenant is AWS configure. You know, I told it I said it at the beginning that you need to do AWS CLI configure. So you need to enter AWS configure from there. I don't want to expose my credentials. That's why.
Okay.
What you need to do is you do AWS. You would have installed AWS CLI on the terminal. So the next thing you do is AWS configure. AWS configure. So once you put it, you can see that I have an existing one there already. That's why you can see my this thing there. So I don't know. Can you see my screen?
Yeah.
So I have an existing one there. That's why you see this is the last four characters of my existing one. So once you put AWS configure, you put your access key, you put your secret access key, and you put the region and also the output format JSON. You put it there. It sounds gibberish.
Okay. Yeah. Yeah. Sulaiman, sorry. To address what Mama just said now, right? Yeah. So for me,
it's not
like
it's not AWS. It's not a networking concept. Do you get? So it's still more of like of the basic concept. This is just AWS configure. Like you want to, I told you that you have 3 ways to access AWS. You have the GUI, the CLI, and the API. So this AWS configure is the CLI part. When I created a user or the other time, I created it with access key. So you will be given access key and secret access key. Those guys is what you're going to put here to be able to put your credentials on this terminal. So anytime you are connecting to AWS, you'll be able to connect directly from here. I don't know if you get my explanation. It's still more, it's not a networking concept, so don't get.
I get it now.
So this error, that's why error is a normal thing. This error says that keep here s_continuum.pem does not exist. The reason is that I don't need to add .pem there again. I just need the value of my keep here. So let me share my screen and show you. My plan was that we won't use up to 1 hour 30 minutes. So you can see that this guy, so you can see that this is the keep here. The keep here is s_continuum. It doesn't have .pem at the back. So this is what I should reference, not .pem. So let me just edit it. Do you get my explanation? I don't know if you get my explanation. Or...
Yes, I do get it.
yeah,
so this is what I should reference. I don't need to put .pem at the back again. So let me just update my Terraform file and plan again, and let me just update it. So let me just go to variable. I just remove the pen. .pem. I don't need it. I just put the name there. Let me save it. And I'm just from Terraform apply. So and this thing, I've already entered some command there already. So some have been created already. So it's how I call it there's this vocabulary they use. It's like Ansible as well. So it doesn't override what you've done before. Since you say that, okay, we've already done apply before, but some were created, other ones not created. So it won't start creating a new one. Since we have a state file that it checks, okay, this state file matches what I have already, it won't create them. It's just created it. It's just created a new one, a new updated one. So you can see that it's starting from web server only. It doesn't need to go to all the VPC, subnet, and all of that again. So I think I'm able to explain that very well. I think it's only sorry, I don't know your name pronunciation. I don't want to fix it up. But she's the only one that responds to my question now. I don't know. Are we also getting it as well?
Yes,
Yeah.
yes.
Sure.
I'm getting it.
Okay. So at the end of the day, this is what we have. So these are what we created. We have created a VPC, security group ID, public subnet, private subnet, and all of that. So this is what we have at the end of the day. So now let's go to our AWS infrastructure and check things. So let's go to VPC. No, I don't mind my network. No, it's good. So you can see web application VPC. I think that's what we created, right? Web application VPC 10.200.0/16. Are we together?
Sure.
Yeah, so this is the sub. So now let's go to subnet. So web application private subnet, public subnet. Can we see? It's there. And it's reference, what the VPC is referencing? It's referencing web application VPC. And let's go to the route table. So can we see we have the private route table, public route table. So let's go to the public route table. Public is the public route table. The guy have associated the public subnet, which is fine. Let's take the route, and also it has associates the internet gateway route based on what you put in the Terraform file. So this guy, this is local. It shows that anybody inside my VPC, like what I've said earlier, people within my VPC, let them be able to talk to themselves. This is just like a default routing. This guy, it comes by default. So anybody inside this VPC, this guy will be able to talk to them because they are inside your house, so you'll be able to talk to them. So it now depends on you with security group and network access list. Maybe you want to start whitelisting something and all of that. But basically, this is the route. You know, routing is different from permission. Routing is the layer 3. Permission is on layer 4 and layer 7 and above. But this routing is just like, okay, if I want to reach anybody in my VPC, okay, there's a route for me to go there. That's why we have that guy. I think that's all we created. So let's check the instance. Let's check the instance. And see. I think we created an instance. What's the name of that instance? This network is slow, right? Yeah, Abdul Malik, you raised up your hand.
Yes. Hello, Suleiman.
Yeah,
I think I've been following up with this tutorial, and it's very, very straightforward. Thank you for that. I'll just need clarification on the Terraform files, just like a very, very brief between the variables.tf, main.tf, and the output.tf. Just a very, very deep overview on that.
Okay, I'll take that again. Thank you. Okay, so this is you can see that this is the public, this is the server we created, and this is the public subnet. The guy is running already. So let's see if we can telnet, if we can SSH to it. But you know, my pen file, I need to find a way to get my pen file. Where's my pen file? Where's that guy? Somewhere I'm coming. I'm trying to open my pen file. Or let me just do it from my laptop. See. Okay, let me open my bash. Okay, going to Abdul Malik question. So variables are like variable. For example, variable is just something like an entity to hold a particular value. Instead of you repeating 10 200 or 10,100, this IP over and over in your Terraform file. So you can just assign them to a variable. So whenever you want to use it in your main.tf file, this main.tf, you just call it main. It can be any name. It can be any name as far it is a .tf extension file. So you can see that let me just go. You can see that this variable.vpc underscore CIDR, it was referenced on the CIDR block. So instead of me putting 10,200 or something here, I'll just reference the variable. That's the work of the variable. So the output here is to show me at the end of the day what has been created. So okay, then I said, okay, show me the value of AWS VPC that has been created, the subnet, the public subnet, the private subnet, and the public IP of my EC2 instance. So this one is like a preference to me. Some people doesn't even have output file in their Terraform file, but it's not a very good approach. But it's good for you to have your output file so that you know what has been created, what do you have for yourself. So this output shows, okay, oh, these variables is what I have, and this is what shows to me at the end of the day. So that's the output. So the major work is on this main.tf. And how does this main.tf works? It references each of the resource, the AWS VPC, AWS Internet Gateway, all of that, it references. I have a project that I did, Transit Gateway. I use a Terraform to implement it from end to beginning, like connecting like 5 VPC together or something like that. So if you understand Terraform very well, it's just a matter of tweaking, changing values, and all of that. So this guy is just like the instruction. Okay, well, create a VPC for me, create a subnet for me, create an EC2 instance for me. And if you want to create an EC2 instance, what do you need? What do you need to be there? You need a subnet, you need a security group, you need the instance type. All these parameters, you need to put it there as well. So that's how it works generally. I hope I'm able to answer your question.
Oh, yes. Thank you.
All right, thank you. Yeah, you're welcome. So let me go to my Terraform. Let me go to my where do I even have my this thing on? It's on downloads. Let me go to my this. Let's copy the public IP. Let's copy it. So I want to show that we can access this public IP, this server from. We can access it through SSH. So SSH-I, we reference the pen file, s continuum.pen Ubuntu servers. The username is Ubuntu. For the other one is EC2 user for Amazon, Red Hat, and all of that. Username is EC2-user. For Ubuntu, the username is Ubuntu. Put the public IP there. Oh, I think the guy didn't copy it very well. So let's copy. Let's edit. So just the public IP of the server. You can see I should be able to enter this guy now. Wow, I'm here. So you can see that I'm on my web server now. You can see the IP address 10.201.75. So this shows me that I'm on a public web server, a public subnet server. This shows that, okay, this guy is a web server or is something talking to the internet. So let's see, ping google.com. You can see that ping.com is reachable because it's an outward call, it's going outside. So I can call Google. I can, let me do a call. So it shows that this guy can reach the internet. So I can view google.com. Can you see? I can access google.com. Let me call Facebook. So it shows that this guy have access to the internet. So, and that's basically what a web server needs to be able to have access to the internet so that you can expose your service and all of that to the internet. I think this one is facebook.com or something. So https/. Yeah, I'm on Facebook. So I think we are all good. So I don't know if there's any question. Um, so let me do a Terraform destroy. Terraform destroy. Should we let's ooh, somebody's raising his hand. I don't want this meeting to be up to 2 hours. You want to, you have a question, right?
Yes, I have a question.
Okay.
My question is about the VPC, EC2, and I mean all the things you said that you want to destroy, so that you won't be charged.
Okay.
I guess that's the reason. Okay, so my question is, I think I sometimes made use of this feature and I was being charged after a while.
You know, it depends on what resource you are using and the time. If you are using a free tier, you can only use a free tier of EC2 of T2.micro servers. You get, you can only make a free tier of T2 micro, this instance type, and the hours when your server will be running also is limited as well. Your storage is also limited. So those guys are limited. So at the end of the day, if you keep them running, Elastic IP will be charged, public IP will be charged if you use Elastic IP and all of that. So you might need to check the billing, something very well. But in between, you've done something that needs to be charged. That's why you are charged.
Okay, so the major thing that really happened to me was after I was done, I shut it down. I did not delete it as it were. I was thinking that would do, but unfortunately, it didn't.
It could be, yeah, it could be this other thing. So so I think, yeah, it could be just the billing. It could be just the billing. So I think it's the billing actually, but you can check documentation. And there are also some ways to get free credits. I'm going to send, maybe in our consecutive session, I'll send some links on how to apply for free credit on AWS, and so that you don't need to use your card or your money to do
Yeah.
that.
So if I may add,
stop recording. I dropped a survey monkey on this chat. Please just try and in the last session we had, we only have 4 responses. So I think just try and use the survey link. Just put your comment, the observation, and all of that. It's going to help as well. I think just to be able to see accountability and all of that, and how to keep this going as well. So thank you very much. I have stopped recording.